here.
Great.
All right, here we go. We did a little bit of work ahead of time. So whoever is absent, we know who you are. But so there were some extra little notes beforehand, which we did. But on page 187, here's what we're gonna do. We're gonna start graphing these rational functions here. So just a quick recap here in Algebra 1. In Algebra 1, you guys learned how to graph lines. And that should be, you should have become an expert of graphing lines in Algebra 1. And the equation to it is y is equal to mx plus, whoa, whole bunch of stuff happening here, plus b. That was the generalized equation. In Algebra 2, in chapter, is it chapter 1 that we did? Polynomial functions?
Totally.
Okay. In Algebra 2, chapter 1, I'll put -1, we learn how to graph any kind of polynomial function. That was super cool. Generalized equation is, and let's be sophisticated here. Now we can do functions now. So the generalized equation for a parabola is a is in front, x minus h squared plus k. Do you guys remember that?
Totally.
Yeah. So there's our generalized equation for a parabola. Just by doing h and k, that moves it across, and a either flips it by reflection, does either a compression or stretch. There it is. That's cool. So now we jump to something called rational functions. There is no generalized equation anymore, guys. Nope, no, none. We're gonna have to do it by parts. So what we do is we simplify it as possible, and we'll get to that, why we do that. And then we're gonna plot, find the y-intercept, and we do it by plugging in a 0 into our function. And we did some of that on the homework that we just did before. Okay, then find the zeros of the function itself. So we're gonna find, placing the numerator, we're gonna put the numerator, set it equal to 0, and find it. Then we're gonna find the vertical asymptotes. And so all we do is we put zeros into our denominator. Then we find the horizontal asymptotes, if any, could be that they don't. And we're going to add in something called a slant asymptote at the end. We'll see what that looks like. We'll do it right at the end here. And then if we have all that information, sometimes we can graph it right away. Sometimes we need just an extra point. I'll put extra point in here because we just don't know the way it goes. We're good? So there. Again, by the time today finishes, you guys will be experts in graphing rational functions. We're good? If you don't fall asleep. If you do, then I can't vouch for you. Okay, so let's go for it. Number 1 is, can we simplify this? Yes, it's already simplified. We're done. That's cool. So 3x minus 2, finished. Good enough there. Okay, next, so we're gonna go in order. The order is not that important because other math books, they place the order differently. We're good. Sometimes you find the vertical asymptote first, like the book that I use in college. We do vertical asymptote first, horizontal asymptote, x-intercept, y-intercept, and then graph it. This book, it does y-intercept, x-intercept, vertical asymptote, horizontal asymptotes, and then graph. So it's just a different order, whichever way you do it. It's okay. Y-intercept. What do? We plug a 0 in for x. That's it.
-1.5.
Thank you. So 3 plugs in, 0 minus 2, -3 halves, or okay. And if we want to, we can actually put it off the side here. It's a y-intercept. So if you want to, you can actually write it like this right here. Just the point that it's going to hit at. And then if that's still not too cool, then you're right, because 2 goes into 3 one time. So -1 and 1/2.
If the y-intercept, then wouldn't the x be 0 and the y would be?
Thank you so much. Let me correct my work. No excuse, no excuse. Totally messed up. That one, or even better yet, negative 1 1/2. That's cool. Thank you. Okay, number 3. It's technically the x-intercept. The x-intercept is when the, and I'll put this right in here, is when the numerator equal to 0. So can I just put a big O N for numerator? Is that okay?
Mhm.
When does the numerator equal 0? It doesn't, because 3 equals 0. I don't think so. Slash that equal sign. Number 4, we're looking for the VAs, vertical asymptotes here. And so what we do is we go back to number 1. It has to be in simplified form. And we think, what is the problem in our denominator still? Whoa.
That's scary. Why?
I think maybe like
Okay, and then we have, let's see, vertical asymptote is any problems with our denominator from the simplified version? It would be x equals to 2. And then the horizontal asymptote.
Oh, the horizontal.
Horizontal asymptote, there's 3 different categories, right? For HA. If it's a proper fraction for degrees. Say again? No? Absolutely. Yep, so it's HO, x to the 0, x to the 1. Oh, another one.
My goodness.
Just another one.
Yeah, no, that was.
Who died on the Who died on the California campus? There's no way to
Uh-huh.
cover it.
No, they're just scaring Joe.
Oh, yeah. Makes sense.
Okay, boom, boom. Based upon that information, guys, can we graph this guy?
Absolutely.
So let's go with it here. So x is equal to 2. We have a vertical asymptote. We can just kind of plot down like this, boom, all the way down. We have a horizontal asymptote, y equals 0. So we can kind of do this right here, just kind of plot these little dashed lines down. And on the homework, you guys will see if it's a horizontal asymptote of y equals 0, they don't do the dashed lines across. I still like to do them because then I know that's where my horizontal asymptote is. Okay, and the dots. We only have 1 dot. That's it. So 0, negative 1 1/2. So if I do this, that is it, guys. That's all I see. I see a dashed line coming down, a dashed line coming across, and 1 dot. Notice I don't have a dot along the x-axis. It's not there. There's nothing there. All right, what does it mean? It means our graph cannot touch the x-axis. Can't go over it, can't touch it, can't go above it, can't go below it. It has to be confined in that space. So see if this makes sense. The only way we can graph this line or this curve so that it hits this little dot is, wait for the punchline, change color. It'd have to start off getting very, very close. Oh, that's a horizontal asymptote, huh? Because you have 2 options here. It's either getting close on top or is it getting close on the bottom? We good? And here's your 2 different possibilities. This guy could either go like this or it could go like this. Which one's the correct one? Yes, it's that little dot that tells us which way we go. Okay, so we can erase that one. We good? Awesome. Then we flip it to the other side. So then the question is, it's going to be flipped like this. It goes, now it jumps to the top. And this one can't touch the x-axis. So it's just going to curve like this and gets closer, closer to y equals 0 as it passes. Done. But that's the easy one.
Nice.
Yeah.
Why is the vertical asymptote equal to?
Okay, sure. The vertical asymptote equals 2 because it's actually not from this one. It's from this one. It's when that is still a domain problem in our denominator. And domain problem is we can't divide by 0. We can't have zeros in the bottom of fractions. So then the question becomes is when is this equal to 0?
Oh, okay.
It's equal to 0, x equals 2.
Yeah.
Okay, Abby, that's the mechanical way of it. Now let's go to conceptual way of it. So If you were to plug in values real quick, let's do the conceptual way of this piece because we'll jump to domain. And so you guys, if I had a 1.9 minus 2, is everything okay? Can I get a value?
Yes.
Yeah, everything's fine. If I had 1.99, is everything still okay?
Total.
Yeah, because I have a number on top, which is 3, and I got a number on the bottom, which is small, but it's still a number. We good? And even 1.999 is just fine. That doesn't cause a 0 on the bottom of my fraction. It's just the fact that when this x turns into just at that single point, 2, now I got myself that number. And it's no longer a number. There's no such thing as 3 divided by 0. Let's jump to this, guys. Let's go for it. This is so fun. Okay, so the question is, why is that not a number?
Because you can't divide anything by a 0.
Oh, awesome. And then for Elika, how come you can't divide a number by 0? This would be fun. This is like a excursion mathematics here real quick. Okay, let's go for it. This would be so cool. We'll write down this problem in a little bit here. So you guys talk to me here. Is this true or false? True, absolutely. 12 divided by 4 is 3. That's so true. Okay, let me tell you like something crazy. I'll tell you to it anyways. In proper mathematics, there's no such thing as division. It does not exist. It's not anything.
Love that.
That's
here,
cool.
got
Oh
it.
no, got totally excited. Okay, I'll let that just sink in the ground. I'll take care of it later. Okay, so there's no such thing as division in mathematics. Everything is either multiplication. In fact, there's no such thing as subtraction. Subtraction is just adding a negative.
Nice.
So with multiplication, with division, it's just a multiplication of a factor to get what you want. So real quick here.
Is this really just 12 times 1 4?
No, it's this right here. It's what multiplies 4 to give you a 12? 3. Awesome. There it is. There's your, in fact, let me write the, boom. Are we good there? That's where it comes from. Okay, so real quick here. Answer is 9 because 2 times 9 gives you 18. Okay, awesome. And that's it. That's the reason why we can't divide by 0. Okay, let's flesh it out just a little longer though. So 0 divided by 3 is 0. How come? Because
3 times 0 equals 0.
awesome. Because 3 times 0 equals 0. Awesome. Okay, let's flip it around the other way. So how about this? How about 3 on top, 0 on the bottom, and we'll put number. Is that okay? We just put a number for number. Ooh, we're modern. It's hashtag. Hashtag. Okay, 3 divided by 0 is hashtag because
0 times hashtag equals 3, but 0 multiplied by anything is 0.
thank you. That is it. There it is. There's our problem. Because it's the multiplication by 0. Can't get out of 0 when you multiply with zeros. Bummer. Okay, you guys learned something awesome, I think.
Was that still answering the question? Why is it 2? Why does that equal 2? Technically.
Are we still answering that question?
Yeah,
Kinda.
kinda. It's like drawing off. Never mind. Yes.
It led to the, yeah, it's an extension of it here. Okay, are we good there? We learned why you can't divide by 0. Okay, real quick here. Guys, do you guys know why you can't divide by 0?
Yes.
Raise your hand if you know why you can't divide by 0. Yes, awesome. Okay, now let's go to our problem here. Ooh, this one's gonna be a fun one. Yeah, and we'll finish up with that one. Okay, we got 15 minutes-ish. I think we can do it. Okay, let's jam with it here. So first things first, is this the simplified version of 2x minus 1 over x? Everybody put your head up and down for a little while.
Wait.
Yes.
Yeah.
Yeah, there's no factoring that needs to take place. There's nothing that needs to take place here. Number 2, what is the y-intercept?
There is no y-intercept.
Oh, awesome. If you plug a 0 in for x, you divide by 0 again, which is not possible. There it is. None, not possible, something along those lines. We're good. Boom. Number 3, give me the x-intercept. X-intercept. Now, x-intercept is we don't care about.
Yeah,
There it is. Yeah. So we're just going to put the numerator set equal to 0. Is there? This one is, huh?
oh, yeah, 1/2.
All right, it's adding 1 divided by 2, and I got myself a 1/2. So 1/2 comma 0 is on my graph. Yes, because as long as I have a dot, now I can go which direction it goes. If I don't have any dots, then I'm in trouble. Number 4. Number 4 is, I think 4 is vertical asymptotes, right? Vertical asymptotes. Vertical asymptote is x equals 0. No wonder it didn't cross the y-axis because I had a vertical asymptote right at x equals 0. And horizontal asymptotes.
2.
Absolutely. Y is equal to, oh, we have ourselves a tie between the 2x and the x. So everybody okay there? Abby, are you good with that one? Cool. 2. Okay, graphic guys, go for it. All yours. Okay, so yeah, almost like I want to work backwards from, so I'm going to go 5, 4, 3, 2, 1. So I got myself my horizontal asymptote. A little bit of Star Wars sound effects. And then my vertical asymptote. And my dot, yes, as long as I have one dot, I'm good. So I got myself a dot right here. That's at 1/2. I think I'm good. Is that right? So the only way this can happen is if notice I'm graphing from the right-hand side instead of the left-hand side now. I would have to be below the horizontal asymptote here. I'm graphing backwards, but that's okay. Boom, and I got myself that. Boom. Okay, the only way the other side can happen is if it started on top and it never even came close to the y-axis or the x-axis. It just stayed on top. That's it, guys. Right there, we've become an expert in graphing rational functions.
That's good.
Well, still the easy one. So next one. Okay, tell me if I'm going too fast as well. Go for it. So next one is, we could do this. Can you guys factor down x squared minus x minus 2 to its simplest form? Because that'll be the easiest way to do it. It's all yours there.
So is that x divided by the?
Uh-huh. So we have x on top. There it is. Boom. And anybody factor down x squared minus x minus 2. Done. Awesome. Okay. And I think we're good enough. Now we can go down this. Since Joe answered first, let's go Luke. So we can blame it on Joe. Okay. So
plug in the 0, right?
yes, plug in 0. And what do we have?
The element for every x. 0 divided by 1 times -2, right?
Absolutely.
0 divided by -2.
Zero to -2 is 0, of course. We're good. Oh, that's weird. Hold on. So the y-intercept Y-intercept is actually 0, 0. That's interesting, okay. X-intercept, numerator equals 0, so numerator equals 0, and it's just, I'm gonna do this one, too difficult, all right. X equals 0, is that right? Is the numerator set equal to 0, which is still 0, 0. So if you get 0, 0 for the Y-intercept, you're gonna have to get 0, 0 for the X-intercept. It's the same dot. Number 4, the VAs.
-1, 2.
Oh, awesome. Okay. Let's see if Elijah heard it. Elijah, what is the vertical asymptote? There's 2 of them. And it comes right back to this one. Perfect. -1 and 2. So I'm not sure how the book wants to write it here. The book writes it like this. It says x is equal to -1 and x is equal to 2. Because technically, let's do some technical stuff here. If you write it like this in mathematics, those are points of solutions to equations, and the 2 solutions are -1, -2. Okay. If you write it like this, you're saying these are 2 different equations. That's one equation. That's another equation. There's 2 different equations because those don't mean points. Those means actually lines, right? Those are lines. Those are vertical lines that are coming down. So we usually write them separate as separate equations, separate lines. Okay, I'm running out of room here. Horizontal asymptote. Landed. Here, awesome. Okay, perfect. All yours, go. This might be a little bit more tricky. In fact, actually, don't graph it. Just kind of put the stuff we know, and then we'll have to do one extra little thing now. Okay, we're getting slightly low on time, so I'm going to go a little bit faster here. So -1. If you want to make the Star Wars sound effects as you do this, this is cool too. And when I solve equations, I'll do like if you like add 3 to both sides, divide by 2. Then you do transformers. Sound effects. Okay, so we got this one, we got this one coming across. Oh, this is so cool. Look at this. We actually have a dot right along our horizontal asymptote. It's right there. There's my dot. Because remember, horizontal asymptotes are talking about what happens at the ends, right? It doesn't talk about what's happening in the middle. Well, vertical asymptotes talk about what's happening the whole entire line. Doesn't touch. Okay, we got ourselves a little problem, and here's our problem. This is interesting. Okay, so real quick here, because we only have one dot. I am in. I know it crosses at x equals. So real quick here, here's my problem. Don't graph it with me. Oh, they gave you at least a forewarning there, Joe. Oh.
Seriously, what is happening?
Something's happening. I got one.
No, see, I thought that it was a car crash because it smelled like gasoline.
And the Parker's coming back.
It's already done. It's everything, yeah. Okay, class, look at this. This graph either goes this way or this graph either goes. Well, let me draw all of it real quick here, but don't draw it with me here. Well, yeah, because I don't know. Here's one possibility. Are we good with that possibility? Right, because it could be from top to bottom, and then we have a switch between these guys each time. Okay, the other possibility, let me graph it with a different. All right, we'll do purple. The other possibility is purple. It went like this instead. This way, because we have no more other dots here, and it went this way. So red or purple? I don't know. So here's what we need to do. We need to add one more extra dot into here, because with that extra little dot, we'll know it all. So pick a number that's not -1, that's not 2, that's not 0. That's the only one we can't use. 3. I heard 3. I'm gonna go with 3. So we're gonna plug in a 3 into this guy. sorry, we're gonna plug in 3 to this guy. We can plug into number 1, the simplified version, because we didn't cancel anything out. We're good. So that's cool. So let me plug in 3 here. 3 plus 1 is 4. 3 minus 1 is 1. Okay. And everybody okay with that right there? Okay, at 3, which is where's 3 at? 1, 2. This was 2, huh? So 3 is here. At 3, the answer is 3/4. Oh yeah, who wins? Red wins. We good? So I'm going to erase the purple completely. So now let me do this. Let me erase the red as well, because then we'll kind of know which way we graph it. Okay, just so we graph it together now. Okay, so back up. Here it is. So because the purple dot over here, let me make it a red dot, because red won technically. Red wins. So there's my red dot. So that means the only way this piece right here can happen is because of this right here. We good? There's that. There's my piece. Now everything falls into place. That means this would have to be at the bottom. That means we crossed right here. That means we went up like this. That means we flip this way, and that means we curve this way. So there's my graph. Dun, da, da, da.
It's
Okay.
kind of a stupid question, but how do you know where to like put the dot?
Oh, sure.
Because I thought that like FX stood for Y.
Talk to me some more. Sorry, talk to me. So, because I did this right here. So let me put in the notation here. We plugged in a 3, and we got ourselves a 3/4. So we got this coordinate right here, which was different from any other coordinate.
Oh, okay, yeah, that makes more sense. Never mind then.
No problem. Talk to me. What made sense though?
I forgot that X equaled 3 because we put in 3 for X.
Okay,
So
gotcha.
yeah.
All right, guys, I'm gonna go a little faster just because of time constraints. I do want to finish up this right here. This one's a little bit more complicated one. Let's jam with it. So number 1, we have to simplify this. So thinking caps on, we got 4.5 minutes. Here we go. X squared minus 9. I got myself, how about a X plus 3, X minus 3. On the bottom, I have X squared minus 2X minus 3. How about X plus 1, I think? X minus 3. Okay, here's our simplification now. Ready?
Cancel X.
X plus 3s are canceled. So we are going to graph something that looks like that right over here. We good? Okay, keep that in mind. Again, ask me questions as we go though, okay? So Y-intercept. Plug in X equals 0 everywhere. Now this one's going to go back to the original one. So if I plug in a 0 here, boom, 0 there, 0 there. And I got myself a 3, is that right? Cool. Okay. So it'll be a 0 squared minus 9. 0 squared minus 2 times 0 minus 3 makes negative 9 over negative 3, or just 3. Cool. X equals 0 gives me Y equals 3. Step 3, my X-intercept now. That's when the numerator is equal to 0.
3. Because then it would be 3 squared. So then it would be 9 minus 5. So it should just be 3.
Yeah, hold on 1 second here. Let me see. I'm gonna go. Sorry, guys, change it up. So number 3 is gonna go simplified version. So we have ourselves X plus 3.
Why is the Y-intercept the complicated version of the X-intercept as opposed to-
Sorry, let's go back real quick here. The 3, number 3, number 4 always went back to the simplified version. Like that.
So it just is like that?
Yeah, because what happens is if we did the regular version, this X minus 3 messes things up. It has never messed things up for us before until now. So real quick here, numbers 3 and 4, we always want to use the simplified version of it. Notice on 2, so let's do this here. On on 2, 3, and 4, we could always go back to the simplified version of it. So I don't know why I made that distinction each time. So always go back to the simplified version of it. Number 4. Number 4 is vertical asymptotes. And here's our stuff. Now, for sure, we have to go back to the simplified version or else we're gonna get it wrong. I guess this way, for number 4, yeah, number 3 as well. Because number 3, you would not get the correct answer here. So 3 and 4 have to go back to simplified version. Okay, vertical asymptotes is x is equal to -1. Are we agreed there? Okay, and then we're gonna put a little comma. You guys ready for this? A whole at x is equal to 3. And we're almost past time. So I've got 45 seconds left. Here it is. Horizontal asymptote is?
Isn't it 1?
It's 1 right here. Boom. Y is equal to 1. Okay, so let's graph this guy. Let's see what we get. And so 0, 3, 1, 2, 3. There's my y-intercept. Here's my x-intercept right there. My vertical asymptote at -1. My horizontal asymptote, y equals 1. There's that. And we're past time here. Okay, the only way this can happen is top goes through our y-intercept turns here. Underneath the horizontal asymptote crosses the -3 along the x-axis and here, and then we got to do one more itsy bitsy thing, guys. We have a hole at x equals 3. So if you're to go out 1, 2, 3, we're going to erase this little guy. And we're going to put a little hole right here, which means not part of our graph. And it goes like that at the end. We are sophisticated and we know how to graph rational functions. Okay, we didn't get to the slant asymptote still, so we're going to have to get to it on Friday. I'm going to say if you want to hold off on the homework still, for that, let's do that. Hold off on the homework. If you want to try some, if you know you're going to get to the slant asymptote, you can stop. But we'll finish it off on Friday. If you want to turn in your 2.5, turn it in right over there.